On the morning of March 14, 2009, commanders of the People's Liberation Army Navy South Sea Fleet convened inside their underground operations center in Yulin Naval Base on Hainan Island, where concrete bunkers housed China's most advanced submarines, and where digital displays tracked every surface vessel transiting the contested waters of the South China Sea. Admiral Wu Xingli, Commander-in-Chief of the PLA Navy, had just completed a tour of the newly constructed artificial islands designed to project Chinese sovereignty across the Spratly and Paracel archipelagos. Chinese naval doctrine stated clearly that control of these waters was absolute, that every fishing vessel, cargo ship, and foreign warship entering the region would be monitored by coastal radar stations, tracked by surface patrols, and deterred by the growing fleet of Type 52D destroyers and Type 54A frigates equipped with advanced sonar systems. Chinese admirals believed their anti-submarine warfare infrastructure had finally reached parity with Western navies, that their network of underwater acoustic sensors, helicopter-based dipping sonar, and submarine hunting corvettes would detect any intrusion into what Beijing considered sovereign maritime territory. They were certain that no adversary submarine could penetrate the defensive perimeter without immediate detection and localization. Yet at that precise moment, 3 United States Navy submarines were operating undetected less than 40 nautical miles from the Yulin base, recording every electronic transmission, mapping every sensor array, and tracking the acoustic signature of every Chinese vessel entering or leaving port. The submarines were Virginia-class and Seawolf-class nuclear attack boats, vessels designed specifically to dominate the undersea domain through a combination of extreme quieting technology, advanced passive sonar arrays, and operational training that turned American submariners into invisible hunters capable of shadowing adversary fleets for months without ever being discovered. What Chinese commanders did not yet comprehend was that their entire maritime strategy rested on a technological illusion, that American acoustic superiority had rendered their anti-submarine defenses functionally irrelevant, and that the United States Navy possessed complete situational awareness of every movement in the South China Sea, while the PLA Navy remained blind to the presence of the most capable intelligence collection platforms ever deployed beneath the ocean's surface. The roots of American undersea dominance traced back to the Cold War, when the United States Navy developed the Sound Surveillance System, known as SOSUS, a global network of hydrophone arrays installed on the ocean floor to detect Soviet submarines transiting the GIUK Gap and the Pacific approaches to the continental United States. SOSUS technology relied on passive acoustic monitoring, listening for the distinctive sound signatures produced by submarine propellers, reduction gears, and machinery noise transmitted through water at distances exceeding hundreds of miles. During the 1970s and 1980s, American engineers perfected the science of acoustic detection, creating libraries of sound profiles for every class of Soviet submarine, tracking individual boats by the unique characteristics of their propulsion systems, and developing signal processing algorithms capable of isolating submarine noise from the ambient sounds of ocean currents, marine life, and surface traffic. By the time the Soviet Union collapsed in 1991, the United States had achieved what naval strategists called acoustic overmatch, the ability to detect adversary submarines at ranges far beyond what those submarines could detect American vessels, creating a tactical advantage that effectively neutralized the threat of surprise attack. The technology did not disappear with the end of the Cold War. Instead, it evolved and migrated from fixed seabed installations into mobile platforms capable of deployment anywhere on the planet. The Virginia-class submarines entering service in the early 2000s represented the culmination of decades of research into noise reduction and sensor performance, incorporating advanced anechoic coating materials on the hull to absorb rather than reflect active sonar pings, redesigned propulsion systems that eliminated mechanical vibration, and the N/BQQ-10V4 sonar suite, an open-architecture acoustic processing system integrating bow-mounted passive arrays, wide-aperture flank arrays, high-frequency active arrays, and the TB-29A thin-line towed array capable of detecting faint acoustic signals at extreme distances. The Seawolf-class submarines, though fewer in number with only 3 hulls completed, were even more formidable, designed during the final years of the Cold War to hunt the Soviet Union's quietest nuclear boats beneath the Arctic ice. The USS Seawolf, USS Connecticut, and USS Jimmy Carter incorporated sound dampening technologies, so advanced that their acoustic signature was described in classified naval intelligence assessments as being quieter at cruising speed than a Lowe's Angels-class submarine sitting motionless at the pier. These boats could approach adversary vessels without detection, record communications intercepts, map underwater terrain, and deploy specialized surveillance payloads, all while remaining completely invisible to conventional anti-submarine warfare measures. China's anti-submarine warfare capabilities in the 2000s and 2010s, by contrast, represented a fundamental mismatch against American technological sophistication. Despite massive investment in surface combatants and coastal defense infrastructure, the PLA Navy remained hobbled by limitations that Western naval analysts had documented for decades. Chinese destroyers and frigates were equipped with hull-mounted sonar systems that, according to assessments published by the U.S. Naval War College and independent defense research institutions, were dimensionally too small to achieve long-range detection of quiet nuclear submarines operating in deep water. The sonars installed on China's Type 52D destroyers and Type 54A frigates were optimized for littoral environments in shallow coastal zones where diesel-electric submarines might operate, but lacked the power and sensitivity required to detect American nuclear attack boats cruising silently in the thermocline layers of the South China Sea. Chinese naval helicopters, essential for rapid deployment of dipping sonar and sonobuoys during active submarine hunts, were acknowledged even by Chinese military journals as a critical weakness. With the PLA Navy possessing insufficient numbers of dedicated anti-submarine helicopters and lacking the operational experience necessary to coordinate effective multi-platform searches across vast ocean areas. Chinese diesel submarines, including the Type 39A Yuan-class boats equipped with air-independent propulsion systems, were capable anti-submarine platforms in theory, but their crews lacked the combat experience and training hours that American submariners accumulated through continuous at-sea operations and realistic war games against peer competitors. Moreover, Chinese submariners operated in an information environment where their own fleet was noisier than they realized, where maintenance standards and operational protocols had not yet reached the rigor necessary to sustain true stealth, and where the acoustic signature reduction measures that Western navies had perfected over decades simply did not exist in Chinese designs. The PLA Navy's most advanced anti-submarine warfare technology remained decades behind the systems deployed by the United States, a gap that no amount of shipbuilding or budgetary allocation could close without the foundational research, operational experience, and institutional knowledge that took the U.S. Navy half a century to develop. American submarine operations in the South China Sea during the 2000s and 2010s exploited this technological asymmetry with devastating effectiveness. Virginia-class boats operating from forward bases in Guam and Japan rotated continuously through the region, conducting intelligence surveillance and reconnaissance missions known in naval terminology as ISR patrols, during which submarines would approach contested features such as Mischief Reef, Fiery Cross Reef, and Sub-I Reef, collecting electronic intelligence on Chinese radar installations, communications networks, and construction activities associated with the militarization of artificial islands. These submarines operated in waters that Chinese commanders publicly declared to be under constant surveillance, yet not a single American boat was detected or tracked during these missions. Declassified excerpts from Naval Intelligence South China Sea surveillance assessments confirmed that U.S. submarines maintained persistent coverage of PLA Navy facilities, recording the departure and return of Chinese surface combatants, tracking the training exercises conducted by Chinese submarine forces, and monitoring the acoustic signatures of new vessel classes as they entered service. The intelligence collected by these missions provided American war planners with complete awareness of Chinese naval capabilities, operational patterns, and tactical doctrines, allowing the U.S. Pacific Fleet to maintain a comprehensive order of battle for PLA Navy forces, and to assess with precision the actual combat effectiveness of Chinese anti-submarine defenses. Operational summaries released in redacted form by Submarine Force-specific documented missions lasting 60 to 90 days, during which American submarines shadowed Chinese naval formations without detection, recorded communications traffic, and demonstrated the ability to position themselves within torpedo range of high-value targets including aircraft carriers, amphibious assault ships, and ballistic missile submarines. The submariners conducting these patrols operated under strict rules of engagement that prohibited active sonar emissions and required absolute stealth, relying entirely on passive acoustic sensors to navigate and collect intelligence. The fact that these missions succeeded month after month, year after year, without a single incident of detection represented an intelligence triumph of historic proportions, comparable to the SOSUS network's monitoring of Soviet submarine movements during the Cold War. Chinese naval commanders gradually became aware that their anti-submarine warfare systems were failing to detect American submarines, but the realization came not from successful tracking or interception, but from the humiliating recognition that U.S. boats were operating with impunity in waters Beijing claimed as sovereign territory. In 2011, a Chinese Naval Research Institute published an internal assessment acknowledging that the PLA Navy's anti-submarine capabilities were weak, and that combat experience is almost non-existent, a remarkable admission for a military organization that rarely publicized its deficiencies. The report noted that Chinese anti-submarine forces relied on non-conventional means, including the use of torpedo-armed fishing vessels, commercial ships converted for mine deployment, and unmanned underwater vehicles for reconnaissance, tactics that revealed the desperation of a navy unable to compete using standard military capabilities. Chinese analysts openly discussed the possibility of deploying underwater drones to compensate for inadequate sonar coverage, acknowledging that conventional methods had proven insufficient against advanced adversary submarines. The Jamestown Foundation, a research organization specializing in Chinese military affairs, published a detailed analysis in 2016 documenting Beijing's long-standing weakness in anti-submarine warfare, noting that Chinese surface combatants lacked modern ASW-oriented designs, that naval aviation forces were insufficient for blue-water anti-submarine patrols, and that the entire PLA Navy anti-submarine architecture remained optimized for coastal defense rather than power projection. The analysis concluded that China faced a vulnerability that would take at least 1 to 2 decades to remediate, a timeline that placed Chinese anti-submarine parity with the United States well beyond 2030, even under optimistic assumptions about technological progress and training improvements. This assessment was corroborated by Chinese military journals, which published articles calling for massive investment in anti-submarine helicopters, maritime patrol aircraft, and advanced sonar systems, implicitly acknowledging that current capabilities were inadequate. The public admission of weakness represented a strategic defeat for the PLA Navy, forcing Chinese planners to confront the reality that their most critical maritime zones were completely penetrated by adversary intelligence platforms, and that no defensive measure currently available could prevent American submarines from operating at will. The operational advantages conferred by American acoustic superiority extended far beyond intelligence collection, shaping the strategic calculus of naval conflict in the Indo-Pacific. In any potential confrontation involving Taiwan, the Korean Peninsula, or territorial disputes in the South China Sea, U.S. submarines would possess the ability to establish a blockade of Chinese ports, interdict supply lines, and destroy high-value naval targets before Chinese forces could respond. The Virginia-class submarines were armed with Mk-48 ADCAP torpedoes, weapons capable of sinking any surface combatant or submarine in the PLA Navy inventory, and equipped with Tomahawk cruise missiles that could strike land targets across mainland China from positions hundreds of miles offshore. The Seawolf-class boats carried even heavier armament, with 8 torpedo tubes compared to the Virginia-class's 4, and payload capacities optimized for extended combat patrols deep in contested waters. American submarine commanders possessed the training and tactical doctrine to exploit their acoustic advantage, approaching Chinese naval formations from positions outside the detection range of Chinese sonar systems, maintaining firing solutions on multiple targets simultaneously, and executing attacks with a speed and precision that would overwhelm Chinese defensive responses. Chinese anti-submarine forces, meanwhile, would be forced to conduct wide-area searches using active sonar, a tactic that revealed their own positions while offering minimal chance of detecting American submarines designed to evade exactly such measures. The result was a military imbalance so pronounced that even Chinese strategists acknowledged it represented an existential vulnerability, one that undermined the credibility of China's naval modernization, and exposed the limits of what shipbuilding alone could achieve without the underlying technological foundation and operational expertise required for modern naval warfare. The technical specifications of American submarine acoustic technology revealed why Chinese anti-submarine efforts remained futile. The N/BQQ-10 V4 sonar system installed on Virginia-class and upgraded Seawolf-class submarines represented the most advanced underwater sensor suite ever deployed, integrating multiple sensor arrays into a unified processing architecture capable of detecting, classifying, and tracking multiple contacts simultaneously at ranges classified but estimated by independent analysts to exceed 50 nautical miles under favorable acoustic conditions. The system's bow-mounted spherical array contained thousands of individual hydrophone elements, each capable of detecting pressure waves generated by distant vessels and processing those signals through advanced algorithms that filtered out background noise and isolated the acoustic signatures of interest. The wide-aperture flank arrays installed along the sides of the submarine hull provided additional bearing information and improved detection of contacts at beam angles, where the bow array might be less sensitive. The TB-29A thin-line towed array, a fiber-optic hydrophone system deployed behind the submarine on a cable extending thousands of feet, offered extremely low-frequency detection capability, allowing the submarine to hear the deep rumble of large vessels and submarines at distances far beyond the effective range of active sonar. The entire system was integrated through open architecture software that received biennial updates incorporating the latest signal processing techniques, machine learning algorithms for contact classification, and acoustic libraries updated with the signatures of new vessel types as they entered service. This continuous modernization ensured that American sonar systems remained ahead of adversary quieting efforts, adapting to new threats faster than adversaries could develop countermeasures. Chinese sonar systems, by contrast, relied on technology that Western analysts assessed as being 1 to 2 generations behind American capabilities, with smaller arrays, less sophisticated signal processing, and operational limitations that constrain their effective range and detection reliability. The quieting technology incorporated into American submarines represented an equally critical component of acoustic superiority. The Virginia-class design eliminated the reduction gear traditionally used in submarine propulsion, replacing it with a direct-drive electric motor powered by the boat's nuclear reactor, a configuration that removed one of the primary sources of machinery noise. The reactor itself was mounted on sound isolation rafts that decoupled mechanical vibrations from the hull structure, preventing noise transmission into the surrounding water. The submarine's hull was coated with anechoic tiles, specialized rubber materials embedded with air pockets designed to absorb incoming active sonar pings rather than reflecting them back to the transmitting source, reducing the submarine's detectability by enemy active sonar systems. The propeller design incorporated advanced hydrodynamic shaping to minimize cavitation, the formation of vapor bubbles that collapse and generate noise as the propeller blades move through water, a phenomenon that historically represented the loudest signature produced by submarines. Every piece of machinery inside the submarine, from pumps to ventilation fans, was selected and installed with noise reduction as a primary design criterion, creating an acoustic environment so quiet that crew members could hear the sound of shrimp snapping in the ocean outside the hull. The cumulative effect of these technologies was a submarine that operated below the ambient noise level of the ocean in many conditions, effectively invisible to passive sonar systems and extraordinarily difficult to detect even with active sonar at close range. Chinese submarines, despite incremental improvements in quieting over successive generations, remained significantly louder with acoustic signatures that U.S. Navy sonar operators could detect and classify with high confidence at ranges where American boats remained completely undetectable. The strategic implications of this technological disparity became apparent in Chinese naval doctrine revisions published in the mid-2010s. PLA Navy strategists began emphasizing anti-access area denial strategies that relied on long-range anti-ship missiles, coastal defense systems, and integrated air defense networks rather than direct naval engagement, an implicit acknowledgement that China could not achieve sea control against an adversary possessing superior submarine capabilities. Chinese military publications discussed the need to develop underwater Great Walls, networks of fixed sensors and autonomous vehicles designed to compensate for the inadequacy of mobile anti-submarine platforms, proposals that revealed the depth of concern about American undersea dominance. The PLA Navy invested heavily in unmanned underwater vehicles, deploying systems such as the HSU-001 autonomous reconnaissance drone showcased in 2019, equipped with side-scanning sonar and magnetic anomaly detectors intended for submarine detection. Yet these systems represented tactical expedients rather than strategic solutions, offering localized detection capability in specific operating areas, but lacking the range, endurance, and coordinated networking necessary to monitor vast ocean expanses or to track fast-moving nuclear submarines capable of transiting hundreds of miles between patrol areas. Chinese strategists openly discussed the possibility that American submarines could enforce a blockade of Chinese ports in wartime, interdicting commercial shipping and isolating the People's Republic from global trade routes, a scenario that highlighted the vulnerability created by inadequate anti-submarine warfare capabilities. The fact that Chinese planners felt compelled to develop asymmetric countermeasures rather than competing directly in submarine technology demonstrated their recognition that the technological gap was too large to close through conventional means. The intelligence derived from American submarine operations in the South China Sea extended beyond tactical surveillance to strategic warning and crisis management. During periods of heightened tension, such as the 2016 South China Sea arbitration ruling that invalidated China's territorial claims, U.S. submarines provided policymakers with real-time awareness of Chinese naval movements, allowing Washington to assess whether Beijing was preparing for military action or limiting its response to diplomatic protests. The ability to monitor Chinese submarine deployments offered critical insights into the operational readiness and strategic intentions of the PLA Navy, distinguishing between routine training exercises and potentially threatening force concentrations. American submarines also collected electronic intelligence on Chinese communications networks, radar systems, and command and control architectures, information that would prove invaluable in any conflict by allowing U.S. forces to jam, deceive, or destroy Chinese military networks before they could coordinate effective responses. The comprehensive intelligence picture assembled from these missions informed Pentagon assessments of Chinese military capabilities, shaped U.S. defense planning and force structure decisions, and provided the foundation for diplomatic strategies designed to deter Chinese aggression while avoiding escalation. The intelligence collection missions conducted by Virginia-class and Seawolf-class submarines represented one of the most valuable and least publicly acknowledged contributions to American national security, delivering strategic advantage that no satellite, aircraft, or surface vessel could replicate. The human dimension of American acoustic superiority rested on the training and expertise of submarine crews, personnel who spent years mastering the art of silent running and acoustic warfare. American submariners underwent intensive training in sonar operation, learning to interpret the subtle acoustic signatures that distinguished friendly vessels from potential threats, to track multiple contacts simultaneously using passive sensors alone, and to navigate safely in congested or hostile waters without revealing their presence. The U.S. Navy's Submarine School in Groton, Connecticut, and the Advanced Undersea Warfare Training Center in San Diego, California, provided multi-month courses in acoustic analysis, tactical maneuvering, and operational planning, creating a cadre of specialists whose skills far exceeded those of their counterparts in other navies. American submarine commanders were selected through rigorous evaluation processes that assessed not only technical competence, but also judgment, leadership, and the ability to operate independently for extended periods without communication with higher authority. These officers routinely conducted patrols lasting months, making real-time tactical decisions based on the acoustic picture developed by their sonar teams, balancing mission objectives against operational security, and demonstrating the discipline necessary to remain undetected even when shadowing adversary vessels at close range. The experience base accumulated by American submariners through decades of continuous operations, war games against peer competitors, and realistic training scenarios created an institutional knowledge that could not be replicated through classroom instruction or theoretical study. Chinese submariners, despite benefiting from expanding training programs and increased operational tempo, lacked the combat experience and institutional culture that had been forged in the U.S. Navy through confrontations with the Soviet submarine fleet during the Cold War. This experiential gap represented an advantage as significant as any technological superiority, ensuring that even if Chinese submarines achieved acoustic parity with American designs, Chinese crews would still face a substantial disadvantage in operational effectiveness and tactical proficiency. The political and strategic reverberations of American undersea dominance extended to alliance relationships and regional security architecture. U.S. commitments to defend Japan, South Korea, the Philippines, and Australia gained credibility from the demonstrated ability to project power beneath the ocean's surface, where geographic distance and adversary defenses could not prevent American forces from reaching critical areas. Allied navies benefited from intelligence sharing arrangements that provided access to acoustic data collected by U.S. submarines, enhancing their own anti-submarine capabilities and fostering interoperability that strengthened collective defense. The presence of American submarines in contested waters served as a deterrent against Chinese coercion, signaling that any attempt to use force to resolve territorial disputes would confront military capabilities that China could not match. The strategic messaging was unmistakable. The United States possessed the ability to see everything happening beneath the South China Sea, while China remained blind to American movements, a reality that fundamentally undermined Beijing's claims of maritime control and exposed the limits of China's regional military power. Chinese leaders understood that their sovereignty claims rested on a foundation that could be challenged and potentially destroyed by forces they could neither detect nor defend against, a vulnerability that shaped Chinese strategic calculations and reinforced the necessity of avoiding direct military confrontation with the United States. The October 2021 collision of the USS Connecticut, a Seawolf-class submarine, with an underwater object in the South China Sea, offered a rare public glimpse into the normally invisible world of American submarine operations in the region. The incident, which occurred on October 2 but was not publicly disclosed until 5 days later, resulted in damage to the submarine's bow sonar dome but did not compromise the nuclear reactor or cause serious injuries to crew members. While the U.S. Navy declined to specify the location or nature of the underwater object, Chinese analysts speculated that the submarine had struck an undersea mountain, a submerged shipwreck, or potentially a Chinese unmanned underwater vehicle deployed for submarine detection. The South China Sea Probing Initiative, a Chinese think tank, used satellite imagery to identify what they claimed was the damaged submarine sailing southeast of the Paracel Islands, demonstrating that even Chinese intelligence collection efforts remained limited to post-incident analysis using overhead reconnaissance rather than real-time tracking of submerged submarines. The collision highlighted both the operational risks of submarine operations in complex underwater terrain and the continuing American commitment to maintaining presence in contested waters despite those risks. The fact that a Seawolf-class submarine was operating in the South China Sea more than a decade after entering service demonstrated the enduring value of these platforms and the U.S. Navy's confidence in their ability to operate undetected in hostile environments. The incident did not alter American operational patterns. Virginia-class submarines continued rotating through the region, and in November 2024, the USS Minnesota became the first Virginia-class boat to be permanently forward-deployed to Guam, ensuring sustained American submarine presence in the Western Pacific. The decision to homeport Virginia-class submarines at Guam reduced transit times to operational areas in the South China Sea, increased the number of submarines available for patrols at any given time, and sent a clear strategic signal that the United States intended to maintain and expand its undersea dominance regardless of Chinese military modernization. The technological trajectory of American submarine development suggested that acoustic superiority would not only be maintained, but expanded in coming decades. The Virginia-class Block V submarines entering production incorporated the Virginia Payload Module, an additional hull section containing 4 vertical launch tubes each capable of carrying 7 Tomahawk missiles, increasing the boat's strike capacity from 12 to 40 Tomahawk rounds, and transforming the submarine into a platform capable of delivering devastating conventional firepower against land targets across mainland China. Future Block VI and Block VII variants were planned to integrate even more advanced sonar systems, improved quieting technologies, and autonomous underwater vehicles that could be deployed from the submarine to extend sensor coverage and conduct reconnaissance in areas too shallow or too dangerous for manned platforms. The U.S. Navy's Acoustic Superiority program, described in congressional testimony and defense research publications, focused on developing next-generation sensors capable of detecting quieter submarines at longer ranges, new coding materials to further reduce acoustic signatures, and signal processing algorithms incorporating artificial intelligence and machine learning to improve contact classification and tracking. These investments ensured that American submarines would remain ahead of adversary quieting efforts, preserving the technological margin that had defined undersea warfare for decades. China's submarine modernization, meanwhile, faced structural limitations that no amount of investment could quickly overcome. Chinese shipyards were building submarines at an impressive rate, but the vessels entering service incorporated incremental improvements in quieting and sensor performance rather than revolutionary breakthroughs, and Chinese crews continued to struggle with the operational experience deficit that separated competent submarine forces from truly elite ones. The gap was closing, but slowly, and American planners were confident that U.S. acoustic superiority would persist well into the 2030s and potentially beyond, providing a strategic advantage that shaped military balance in the Indo-Pacific and deterred Chinese aggression across multiple potential flashpoints. The ultimate lesson of American submarine operations in the South China Sea was that maritime control could not be established through surface vessels, coastal installations, or artificial islands alone. True dominance required the ability to operate beneath the surface, to see without being seen, to strike without warning, and to deny adversaries the situational awareness necessary for effective military action. The United States had achieved this capability through decades of sustained investment in technology, training, and operational experience, creating a submarine force that rendered Chinese anti-submarine defenses irrelevant and exposed the fundamental weakness at the heart of Beijing's maritime strategy. Chinese commanders who claimed total control of the South China Sea had built an impressive surface fleet, constructed elaborate coastal defense networks, and deployed thousands of personnel to monitor and patrol contested waters. Yet beneath the surface, American submarines listened, watched, recorded, and tracked every movement without ever being detected, demonstrating that the ocean's depths remained an American domain where Chinese power could not reach and Chinese sensors could not penetrate. The invisible advantage of acoustic superiority proved more decisive than visible displays of naval strength, revealing that in modern warfare, the forces that remain unseen often determine who truly controls the sea.